Okay, I wanted to take you through the math problems for 5B. So take out your 5B study guide. We will get through the rest of it, but I did want to take you through the math problems for those just for today. All right, so for number 10, we've started off with a frequency of 7.79 times 10 to the 5th hertz, or s to the negative 1, and it wants to know the wavelength is what we're going for. Okay, so if we list out our known and our unknown here, I know that my frequency is 7.79 times 10 to the 5th hertz, and my unknown is wavelength, and it needs to be in nanometers. So the equation I should have used would have been the speed of light equation, and you will get this stuff up here on the quiz. Okay, so you don't have to memorize any of the numbers, you just have to know how to use them. Okay, so you would have had c equals the wavelength times the frequency. Now we always know that c is equal to the speed of light, which is 3.0 times 10 to the 8th meters per second. We're looking for the wavelength, and they gave us the the frequency of 7.79 times 10 to the 5th. Okay. If you need to go back and look at this video again, I will put it in the resources section of eChalk if you need it. Okay. So if I plug and chug, in order to manipulate it, we got to divide both sides by 7.79 times 10 to the 5th. Okay, that's going to get me a wavelength value of 385 meters, but I'm not done yet because it wants it in nanometers. So then I have to take my 300, and keep 3 significant figures because I always use my data, and since the original problem had 3 significant figures, my data needs to be 3 significant figures. So 385 meters, I've got to convert it to nanometers. 10 to the 9th nanometers, 1 meter. So my final answer here is going to be 3.85 times 10, see if I can squeeze this in here, 10 to the 11th nanometers. Okay, 10 to the 11th nanometers. And the next part of the question says, does this light have a larger or smaller amount of energy than violet light? Okay, like I said, you don't have to actually do the math on this. You just have to go back to the electromagnetic spectrum. And if you remember when we did the electromagnetic spectrum, in the middle here we had Roy G. Biv. This was the high frequency, low frequency, low energy side. This side is the higher frequency and the higher energy side. So all we have to do, since we know we're talking about if we come back to what the question asked us here, it said, does this light have a larger or smaller amount of energy than violet light? We just have to find the two on the electromagnetic spectrum, and since ultraviolet is towards the higher energy, higher frequency side, the answer is going to be more, okay, or larger. It's going to have a larger amount of energy than violet light because it's further along on the electromagnetic spectrum. That part's stuff is not on the quiz, just the math. Okay, now if we come down to number 11, if we do the known and the unknown, we want to know the energy, and again we're given frequency here, which is going to be 6.43 times 10 to the 4th hertz. Okay, well this time, instead of wavelength and frequency like I mentioned down here, now we're talking about energy and frequency. So the equation that we have to use here is E equals hv. H is equal to Planck's constant, which again was given up above. You do not have to have that memorized. So I've got E is equal to 6.626 times 10 to the negative 34th times our frequency, which is 6.433 times 10 to the 4th. I multiply these. They're already set up for success, so to speak here. And don't forget to use parentheses because otherwise you'll get the wrong exponent. My final answer here needs to have 3 significant figures because of the data. And if I do this on the calculator, I should have gotten 4.26 times 10 to the negative 29th joules. All right, and that's my final answer for energy. These are the two types of problems that are on the quiz. Now it also asks me here, it says, does this radiation have a higher or lower amount of energy than X-rays and gamma rays? Okay, again, you've got to go back to your electromagnetic spectrum. This is the side that has a high wavelength, so it's going to be low frequency and low energy. So since microwaves are more to the lower side than X-rays and gamma rays, the answer to this one is going to be a lower amount of energy. So you'd still need to be familiar with that electromagnetic spectrum. Okay, I'm going to go ahead and do the math for the skills review, just because we can, and we will do the rest of the 5B study guide the next time that I see you, which hopefully should not be too much longer. Okay, so for this one, we kind of switch gears. We go back to the moles to grams stuff, and the known here was 32 moles of copper. The unknown is grams. No mention of atoms, so the conversion factor that we have to use is molar mass. So we start with 32 moles of copper, and we want to get rid, or we're coming from the mole unit, so that's what's going to go on the bottom. What we figure out is going to go on top, and you're not going to be able to see the numbers here. We have to find copper on the periodic table and find the number that has the decimal places in it. Okay, it's really tough to see, but if you look at a periodic table, the number with the decimal places is the average atomic mass. And for copper, it is going to be 63.55 grams. So now, since these two numbers are on the top, we're going to multiply them. We're going to have two significant figures because of our data, and our calculator gives us 2033, and the only way to get that to two significant figures is to write it as 2.0 times 10 to the third, and it's grams of copper. Okay, and that's the answer to the first one. Alright, the second one, we start off knowing that we have 1.87 times 10 to the 50th atoms, and we want to know the amount of moles. Okay, here we get into the atoms. We're still just doing moles. So we got to use Avogadro's number. So I'm going to have 1.87 times 10 to the 50th atoms. Now this time I want to go 2 mole. The mole always gets the 1, so we're going to have 1 mole of oxygen up top, and then I've got to put Avogadro's number, 6.022 times 10 to the 23rd atoms of oxygen on the bottom. I've got to divide them. So on my calculator, 1.87 times 10 to the 50th divided by 6.022 times 10 to the 23rd. I'm going to have 3 significant figures because of my data here. So when I do this math, it's going to come out to be, let me see if I can squeeze this in here, 3.11, I'm going to have to go on 2 lines, times 10 to the 26th, and it's got to be atoms of oxygen. All the parts and pieces are labeled, correct unit on the final answer with significant figures, but the final answer should have been 3.11 times 10 to the 22nd atoms of oxygen. Okay, for the last one, the unknown here is the number of atoms, so we're going to have to use Avogadro's number, only we're starting with kilograms. So my known here is 8.97 kilograms of tungsten. It's going to take me more space, so that's why I'm going to do it this way. So I'm going to have, give myself some more space here, 8.97 kilograms. This is probably a tougher one. I'm going to do it all together here to show you what it looks like. I got to cancel out. Now if you find tungsten on the periodic table, it's a W. Now the first thing I have to do is go to grams. I do that by 1,000 grams of tungsten and 1 kilogram of tungsten. That gets rid of the kilogram unit. Now I've got to go from grams to moles. And in 1 mole of tungsten, I've got to go back to the periodic table. Here's tungsten right here. Atomic number 74 means there's 74 protons. And I got to find the number with the decimal, which is up here. It's tough to see on this one, but if you look on a periodic table, you can find it. And the molar mass of tungsten is going to be 183.85 grams of tungsten. So we cross that off. And then last but not least, we're almost there. It wants to know atoms, so I have to do one more step. 1 mole of tungsten is going to go on the bottom. 6.022 times 10 to the 23rd atoms is on the top. When I do this math, I'm going to go left to right here just to show you. I take 8.97, multiply it by 1,000, take that answer and divide it by 183.85 because it's on the bottom. Take that answer and multiply it in parentheses by 6.022 times 10 to the 23rd. What I should get is 2.94 times 10 to the 25th atoms of tungsten. Okay. All right, and also when you take the quiz, don't forget we always have to do, just like we saw up here, the known and the unknown. Whoops, we do the rest of that later. The known and the unknown, the equation, the work, sig figs, unit, the whole deal. Okay, I hope that helps. Good luck on the quiz.